Continue to talk about triangles like we mentioned. This lesson is titled Congruent Polygons, but like I said, mostly we'll talk about triangles. We're going to look at some other shapes though as well. Our learning targets is that students will be able to identify and use corresponding parts. So we've seen this word corresponding before. We're going to define it in a very similar way to what we've seen in the past, but just a little bit of a change. Students will be able to use the third angles theorem. We kind of already know what that is. We actually kind of used the third angles theorem when we looked at this problem right here. We just didn't know it. We're going to put a name to it. Order of operations, terms, theorems, examples, practice.
Triangle.
So here's what?
Triangle.
Triangle. Yep. Here's our first term. A rigid motion. What's a rigid motion?
Something.
Yep. A translation is one of our rigid motions. Yep. A reflection is a rigid motion. And what's our last one? Translation, reflection, and rotation. Rigid motions. We're just changing location, not changing size. So a rigid motion maps each part of a figure to a corresponding part of its image. Okay, so all that's talking about is that, again, a lot like we looked at in that example problem, is that we would say that corresponding angles would be angle A and angle D, D and E, C and F, just like it says below. I mean, in common terms, we would say angle C is the same as angle F, and that's how we would set it yesterday and set it in that homework example. But if we're using the proper definitions and everything, we would say angle C is a corresponding angle with angle F. Okay, so pretty straightforward. I would write down that sentence at the top of, so we can define a corresponding part. That picture is helpful as well. Not only do we have corresponding angles, but we also have corresponding sides. So earlier we have said that like BC is the same as EF. To further that definition, we would say BC is corresponding to EF. And notice that the reason that we can define it as corresponding is saying that we could use one of our rigid motions to put one on top of the other. So if we needed to go from this triangle to this one, then if we wanted to, then we would be able to like rotate it and reflect it, or reflect it and translate it, or use our rigid motions to put one shape onto the other. Do we have questions about this idea of corresponding parts? Okay. Like I said, we've been talking about this stuff over and over. Now we're just putting a different term. So a way we might see that in a question. Write a congruence statement, we'll talk about what that is in a second, for the triangles. Identify all pairs of congruent and corresponding parts. So a congruence statement is this right here. If they say write a congruent statement, that's what we're looking at. So we just need to identify what are the congruent parts of this triangle. So if we have angle L, well, that red's pretty hard to see, isn't it? We have angle L. What angle is that congruent to? Yeah, Anastasia?
R.
Angle R. What about angle J? Kaylee, what is that congruent to?
T.
It's angle T. What about, which one is it? Angle K? Marissa, what is angle K congruent to?
Yes.
Can't see? You don't pull up on your iPad?
No,
It's dead.
yes.
You want to charge it? I can throw it on the charger. instead, then we probably don't need it up to hide our phone number.
What else side can I?
Not on right now. Angle K would be congruent to angle S. And if you can't see from back there, then there's plenty of spots closer up so you can see the board because that's important. So those would be our angles that are corresponding. Now if we look at our sides that are corresponding, notice we list them just like we would a line segment. So if we look at JK, Sawyer, what is JK? What's corresponding with JK?
Let me take a look real quick. JK is ST.
Yep. ST, let's see, JK, and then what about JL? Anastasia?
I actually have a question about
Yeah.
one before.
Sure.
Would it be TS
Instead of ST? Oh, because we start with, I see what you're getting at, but if we put it like that, it would probably be more correct, if I could say it that way. But technically, to say ST would still be correct because ST is the same thing as TS. Are you following with me?
Yeah.
If we went TS, yes, that would probably be more correct. It would probably be the better way to list it. But I would take those ones.
Can you confirm the other one before?
Yeah.
TR.
TR. And then, where am I going? I'm missing one. Which one am I missing? Oh, KL. Who am I talking to yet? Taylor. Which one would be congruent to KL?
ST.
It would be ST.
Oh, no, I'm sorry, SR.
Yeah,
I was looking at the
SR.
wrong one.
No, you're good. SR. Good. Pretty straightforward. Right? The tick marks and the angle measures, the little loops on the inside helps out a lot. Now here's a more complex example that we would see. In the diagram, D, E, F, G is congruent to S, P, Q, R. Find the value of X and find the value of Y. So, notice the way that they list these, okay? D, you can't see that color very good. D maps onto, or that angle would be congruent with the angle S. So these would be congruent. E is congruent with P. Okay, and so on. So each one maps onto the kind of the same order on each side. So obviously, the figure on the right would need to be rotated around to totally match and be side by side with the figure on the left. But we can still solve for X and Y without rotating it around. We can just kind of look and imagine that's what it's doing. So if we're finding the value of X, we're looking at this angle here, Q, third one in line. On our first image, which angle measure does Q congruent with? The 68, good. Over here. So we can set up, if we're looking for X, (68) equals 6y plus X. Now we have two variables involved there, which is not ideal. So maybe if we can use something else to help us solve for one of the variables, then we can plug it in, make it a little bit easier for ourselves. So we have this, I mean, if we could solve for X, like we have up here, the then that might help us out if we do that first. Okay? QR, this line segment. What does that match up with in our first figure? What does that match up with? 12. Good. So if we solve for x, 16 equals 2x.
8.
X would equal 8. Now if we go back over here, now we can find y. So we already figured out part A, we found x. Now we can use that x to help us solve for y. 60 equals 6y. Y would equal 10. Good. That was a little bit more, more complex than this example. You guys have questions on this one? Sawyer, you doing good? Questions?
Yeah, I'm good.
You good? Taylor? You alright? Okay.
Well, physically.
Alright. Theorem 5.3, properties of triangle congruence. These are something that you will definitely want to have down. So, triangle congruence. It's kind of some rules with triangles. Triangles are reflexive, symmetric, and transitive. So take a second to get those down, and then I will talk about each one of them quickly. Yeah, at least they folded it.
The class once, I'm almost done with the assignment.
So these are pretty, they have weird names, but each of these terms or properties, I guess, totally makes sense. For any triangle, ABC. ABC is congruent to ABC. So every triangle is congruent to itself. We call that the reflexive property. Kind of makes sense, I'd say. The symmetric property. If triangle ABC is congruent to DEF, then DEF is also congruent to ABC. So we can flip them around and they're still congruent to each other. Transitive property. If triangle ABC is congruent to DEF, and then triangle DEF is congruent to JKL, then ABC is also congruent to JKL. We see this with addition. Also, A plus B. If A is equal to B, and then B is equal to C, that means that A is also equal to C. That's the transitive property. So the transitive property also applies to triangles. have questions on those, like I said, the terms are a little bit different, but the idea is not too bad. Now, the third angle's theorem. Third angle. The two angles of one triangle are congruent to two angles of another triangle, and the third angle are also congruent. That's exactly what we looked at with, what number was that, Kaylee, on homework, like 14 or 15 or something? On the back side, the last one we looked at, 15 maybe? Yeah, that's exactly what we looked at with 15. If two of the angles are already congruent to each other, then that means this third one has to be congruent. It has to be congruent. So we would apply that third angle's theorem in a question. This is a more complex one where, well, I'll say this is the middle of the road for how we would apply that third angle's theorem. We would need to find the measure of angle BDC. So we need to find this whole thing right here. I'll fill these in different colors to help make it a little easier to see. Oh, it's a little bit off. We go like that, so that we can see what it's like. We are looking for measure of angle. What do we think? How do we approach something like this? How do we even start? What do you think, Anastasia? How do we even start?
Maybe trying to find all the favored ones.
Yeah, that's how I would start out. I would just take what they give me and make sure I can get all the information out there. So they say over here, this angle is 30 and it's equivalent or congruent to this angle, so that also has to be 30. They say that up here, angle A is 45, so that means B also has to be 45. So if we start with what we know, then that can be very helpful. Now if we look at the red triangle, do we already know what two of the sides are? So are we ready already to find angle D? How would we do that? We know the total triangle has to be 180. Emma, how do you think we would do that? Find angle D.
We would
Not sure?
what are we finding in D?
Yep. Angle D right here.
And we just have to wouldn't it just be 180 minus 45?
Yeah, exactly. Nice job. We know that the triangle has to have a total of 180. We know that one side is 45 because we took the information that they already gave us, like Anastasia said. We know that the other angle is 30. So we just need to subtract both. So that would mean that angle D, the whole measure of angle D would be 105 degrees. And again, nothing, what? Nothing that we haven't seen, but just putting it in a little bit of a different context. And I know that that one can look a little bit confusing since the triangles are overlapping. Is that the last? Yeah. As some of you guys have already found out, the assignment's on big ideas. Before you get started on that, I need to see these two problems done before you get started on the big ideas.
Do I have to do them?
Yes.
I got every single question right on the big ideas already.
Well, technically you weren't supposed to start on the big ideas yet.
I got 0.7 of a question